Good evening. This is the chapter meeting for the 17th of May 2022. This evening's featured talk is going to be about the past, present and future of Log4J. And so we've got Ariel and Yuval from coralogics.com, and they're going to tell us about that. First off, I'm going to tell you about OWASP. OWASP is the Open Web Application Security Project. It's a non-profit foundation that's devoted to improving the security in the real world of software. It's a global thing. There's lots of local chapters. We're in the east of the UK, but there are more than 200 other chapters. Things you might have heard of from OWASP include the OWASP Top 10, which is the famous list of security vulnerabilities that people need to be aware of when they're developing software. But there's also interesting things like Zap and Juice Shop, which are very interesting tools. So OWASP does more than just the top 10. We do talks, we do demos, we do tutorials. We did one recently on passwords, and we've got one coming up on backup strategies. Backups and archives are those two things that people are always unsure about, and so we're going to talk about that. Here's the agenda. I'm just doing the introduction bit. We're going to get the talk next. Ariel and Yuval tell me that you can interrupt them and ask questions during the talk, but the main question and answer session will be at the end. Here's the important information about how to follow us. So there's a chapter page for OWASP Suffolk. You can find us on Meetup. We have a Twitter feed, and our videos and etc. are on YouTube. So there's quite an interesting collection of stuff there. So here we have Ariel and Yuval from Coralogics. People always think that logs are boring. Logs are actually really interesting. Logs, traceability, trends, all of that stuff is the sort of thing where people always think that security is all about breaking into places and doing it from outside. Coralogics is much more about stuff that you can observe in your own set of data. So it's getting insights and trend analysis, boiling the knowledge out of things like logs, metrics, tracing, security data, etc., etc. So it's all the observability stuff. So it's all that inside information that it's so easy to ignore, but it's actually incredibly useful. Coralogics are one of the experts in exactly this. So I could do the standard bios and say that Ariel is the co-founder and CEO, but I'm sure he's going to say that. We've also got Yuval, who's the chief security architect, but I think it's always much better if I don't talk about it, but I let them talk about it. Welcome. It's a great pleasure to have you, and over to you.
Thank you very much, Martin. So before we share the presentation, I'm Ariel, CEO of Coralogics. This is Yuval, our chief architect for security. I'm going to share my slides real quick, and what we're going to do today is cover a bit of the latest breach at Log4J. Let me quickly share. So first off, myself, Ariel, CEO at Coralogics, started my career in security at the 8200 intelligence unit in Israel, founded Coralogics in 2015. What Coralogics does is in-stream data analysis, which means instead of analyzing the data after it's stored or indexed, we analyze everything in stream. That includes the stateful stuff. So that includes long-term alerts and trends. And that brings our clients better performance, better scale, better stability, and typically a lower cost, roughly 70% lower than the closest competitor. So overall, all the features you need for logs, metrics, tracing, and security, with endless possibilities of visualizations and syntax queries at a third of the cost. And with me is Yuval, our chief security architect here.
Hi, pleased to be nice to be here. I'm in CoreLogics for about 3 years now, leading the security, the development of security related solutions. Build a tiny word processor when I was 15, that kind of thing.
So what we're going to do today, first of all, a quick dive into observability, so not really a dive into it. And then let's talk a bit about the Log4J incident. What was it? What happened there? And this is going to be a discussion between me and Yuval. So you guys can really jump in and ask questions or extend the conversations. We're going to leave 15 minutes at the end if you have broader questions or things that are off topic. But if you have anything you want to add to the discussion, feel free to jump in. After that, we're going to talk a bit about the post Log4j incident. What action items can we take as organizations to protect ourselves? And then the following Spring4Shell vulnerability that was detected. And how can you protect yourself in the future? How can you make sure that there are some things that you never expect? How can you make sure that you have the proper tool set to identify and remediate? We'll have a few words about how CoreLogics approaches this problem with our security traffic analyzer that analyzes all the mirror traffic and both give compliance and ability to search data, but also intrusion detection and prevention. And at the end, we'll talk a bit about our conclusions from these incidents and answer some questions that you guys in the audience have. First off, a bit about why we think that logs, metrics, tracing, and security information intersect. We believe that analyzing everything together in a single pane of glass allows our customers to correlate security events with performance, with application events. So we're in a modern world now where things are not really siloed. There's no IT department and R&D. Everything runs in the same environment. Everyone utilizes the same resources. And so an application upgrade during the CI/CD process can definitely impact new breaches and new vulnerabilities that you expose. A new package that the developer installs, like Log4j, definitely affects the quality of production, but also affects the security of your production, and vice versa. Security actions like blocking ports or IPs or changing policies can immediately affect the performance and the usability of the system. So having everything together in a single pane of glass allows us to see cross effects, easily analyze, detect faster, and resolve faster. And then when we have everything together, there are some approaches that go with predefined sets of alerts and dashboards. We also do that, but we figure that tailor-made alerting is one of the most critical things when you start protecting your environment. And so we created a group in CoreLogics called the Security Resource Center that works together with customers to define alerts that are tailor-made for their organization. The idea is that the behavior of your organization and the norm of an organization is the base on which we build the alerts and make sure that we identify everything that is out of the ordinary or anything that the organization defined as outside of policy. The organizational benefits of having logs, metrics, tracing, security together and having the right set of tailor-made alerts and dashboards is that you create awareness within the organization, also inside the security, but the engineering team too. So you're going to have a team that is minded for the security of your application and your environment. You're going to have developers that understand security threats and see security threats together with their data, so they can be more proactive, and you can actually shift the protection of your environment and application from post-production to all the development stages. Once you have support teams looking at data, you just have more eyes on the data, and you have also the other side, which is security people being more minded to what's happening on the application there. Sometimes, for instance, a DDoS attack, a very simple one, can cause latency on the APIs. Those things might be overlooked by the operations team that might just decide to scale, but having security eyes on it may identify a pattern or something that we might want to remediate. And you basically get a better stand of security inside your organization and prevent issues from happening. So after this quick intro, let's talk a bit about the Log4j vulnerability. Yuval, I mean, you've investigated for a while, and we've released a report to our customers on how to analyze and everything. But let's start by kind of getting a better understanding from you of what was that vulnerability at all.
Okay, so the Log4J vulnerability is actually an interesting case that represents many other types of similar vulnerabilities, in which an application that was designed to do something has more functionality built into it than what people usually think. In this case, Log4j is a logging framework used by probably almost all Java applications. And for years, we have been telling developers that it's important and critical to log pretty much everything, every action of the application. So the popularity of Log4j grew and grew in order to improve the security of those applications. But as a result, what actually happened is that in Log4j in 2013, they have introduced a new feature that allows users of or developers that use Log4j to send the Log4j just a placeholder that the Log4j would automatically resolve using an API called the JNDI, an API in Java that allows Log4j to do lookups of values that you send to the log. That would essentially save the trouble for a potential developer that, for example, if they want to log the username of a user, instead of having to query an LDAP server to get the actual username, the actual first name, last name, departments, and such of that user, they can just send the username itself in a specific format to the logger, and the logger will itself connect to the LDAP server, bringing this information.
To enrich the log?
To enrich the log while it is being logged.
Right.
And that feature was enabled by default. And this is exactly I think the main thing that allowed this vulnerability to become so critical, because this feature was enabled by default. Even if you didn't need to do any lookups, this feature was enabled by default, and that actually caused made it possible for potential attackers to send data to servers, let's say web servers and such, in headers that they knew that would be logged eventually, and causing the logger on the backend server to do queries against an LDAP server. And as a result, it was also possible for
Yep.
Sorry?
Is there a question from the audience? Someone just forgot his microphone. Okay.
Okay, so so it was also possible for Log4j to query an LDAP server, get a payload, an executable payload, and run it on the server, and that completed the vulnerability by allowing any attacker to send any payload, any payload that would trigger the JNDI lookup against an LDAP server that he has access to send executable code to that server,
So
which will eventually run
the LDAP server that I, the hacker, own would enrich the log with basically an executable.
Yes,
code.
With the output of an executable code.
And that allowed me to basically run everything that I want. The data is not sanitized anywhere?
I mean, if you didn't bother to sanitize your input, no one did it for you.
Got it. And then that vulnerability was introduced, what?
In 2013.
And existed for 8-9 years?
Yeah.
And do we know of any events in which it was actually abused by an attacker or organizations that suffered from this vulnerability?
Prior to being publicly released?
Yeah.
I'm not aware of any organization that was attacked that way before this became publicly disclosed. But I would say that I'm guessing that probably nation state
intelligence agencies and so on,
or intelligence agencies probably detected it, because it's if you investigate, if you look really hard on the code or do some tests on a vulnerable server, it is possible that you found out about it, and such intelligence agency will never disclose it to the public. So I'm guessing that that has been used before, but I don't know of any such evidence.
And who decides that a feature in open source so broadly used like Log4j is switched on by default? Like, is it the community? Is there a committee? Or
basically it's the community. I mean, you can in this case, Log4j is managed by the Apache Foundation, Apache project. So you can send your own change to the code as a PR, and if
it's accepted as default,
if it is accepted, it is merged in.
So now we know what the vulnerability was, and then we also kind of know why it happened. But if we can dive a little deeper into that, what do you think is the cause for this?
The cause for this, I found a quote by the Rugged Manifesto by Jeff Williams that said, "I recognize that my code will be used in ways I cannot anticipate, in ways it was not designed, and for longer than it was ever intended." I like it very much, because I think that this is exactly the problem here. When you develop something, especially if you develop a library that is so widely used, it is imperative that you would take into consideration that this code, this library that you develop, will be used in so many ways that you cannot anticipate. So you must try to enable by default only the minimum features that are crucial for this library to work. Allowing the user to select other configurations and if it's a library, by sending a certain parameter or something like that, that would allow it to do more than that, this is acceptable, because that means that someone intentionally, knowingly made that decision, which makes it reasonable. But doing this decision for your client or for your developers, this is something that is, I think, unacceptable. And I think and another important thing about the Log4j is that since it's a library of a compiled code, that means that changing it, even if you do find a vulnerability and then choose to release a new version, it's not like anyone can just go ahead and do an installation of it and be done with it. That means that every software package that uses it needs to be recompiled, and potentially the code of this application needs to be modified, because if they, for example, use an older version of Java or something like that, they need to change their dependencies, maybe, which would make it so hard to overcome a vulnerability like that. So
we're mostly a Scala shop here, and
yes,
we had a long weekend upgrading on Log4j. About 100. So in CoralLogix, we upgraded about 150 services in a single weekend to remove this vulnerability, and then we'll talk a bit about how things evolve. But we had to do it 2 more times. So a bit about the timeline of events. And the reason we're diving into the timeline of events here is that it was longer than many vulnerabilities after publishing. So the event was found on December 9th. And then after it was patched, a second vulnerability was found in version 2.15. And then 3 days later, a third vulnerability was found in version 2.16, which is, I think the third one was a little less easy to exploit from what I recall. And then the fourth was discovered in 2.17. What can cause such chain of events where things, instead of just getting patched once, are continuously happening and forcing companies to upgrade again and again?
Well, first of all, we need to think. I think that this timeline should start earlier, because first of all, the vulnerability was created in 2013, and then on November 24th of 2021, it was privately disclosed to Apache by the Alibaba developer, software security engineer who detected it. And then on December 6th of the same year, they first released the first patch to address it in version 2.15. And the first thing that they tried to do is to restrict the servers and protocols that may be used for lookups. They didn't bother to disable JNDI lookups entirely by default. They just tried to do some sort of a damage control by restricting the protocols and servers that can be used for these lookups.
It doesn't really make sense. I mean, the first, it doesn't, like, enrichment is great for logs. It doesn't sound like the most critical thing in a logger, and I guess first step that should have been taken to shut down this API, right?
Yes, I think that once you being a developer for so long, I know that when you develop a feature, I don't want to use strong words here, but I think that you sometimes fall in love with your feature that you have developed. You don't want to kill it so fast. So even if you get a report that this contains a vulnerability, you try to address it without losing the functionality. So this is exactly what they did. They tried to restrict the servers and protocols that may be used for lookups. But eventually, when the vulnerability became publicly disclosed on December 9th, researchers found that it is actually, in fact, still vulnerable, even with this first patch. So they created a second patch on December 13th, and which disabled the JNDI by default, which is the good thing to do. Which should have been done as the first measurement of mitigation plan. But while doing that, and I think that the reason is that they did it maybe too quickly because of the pressure that they were under, and that introduced actually two new vulnerabilities. One allowed denial of service attack by an uncontrolled recursion on one of the in one of the functions, and also another vulnerability that allowed remote code execution by using JNDI in JDBC the JDBC driver. Yes.
But wait, didn't that API shut down?
So, no, the API is available, but
by default they close it.
Yes, but the problem was that it was still possible to send special strings that would use it in JDBC, not in the Log4J for logging. So they had to do that too. And on December 17th. They limited the JNDI to Java protocol only, which kind of solved the problem because the problem was mainly with LDAP servers. And on December 28th, they actually released a fourth patch, which made the JNDI even, let's say, harder to turn on. It's not just enabled by default, but it's also required another setting to be enabled, and after that, newer versions of the GRE of the Java runtime environment allowed some
additional mitigations to it so that the problem was
overall, 20 days of vulnerabilities and one of the most commonly used open source loggers in the world.
Yeah, crazy.
So a bit about the implications. I think we discussed some of them, but what do you have to add here?
So about the implications, according to Wiz and Ernst & Young, the vulnerability affected 93% of enterprise cloud environments. This is incredible, unbelievable amount of organizations. The director of the Cybersecurity and Infrastructure Security Agency in the US, Jen Easterly, described the exploit as one of the most serious I've seen in my career, if not the most serious, explaining that hundreds of millions of devices were affected. This is unbelievable.
And all the engineering time that went to waste. We're talking thousands of years of work.
Unbelievable.
And this part of Log4j was actually contributed by like a single contributor, right?
Yes, that's what I heard.
That's the most expensive piece of code ever written, I guess, since Apollo. Probably.
Yes, most likely.
And then so it was resolved after the final fix of 2.17.0.
Yes.
And then after that, we're not aware of any more vulnerabilities or any more risks, or at least not that we're aware of from Log4j. So let's do a quick postmortem on this. What do you think went well on how Log4j was handled?
I think that they did try to do the best in responding to this vulnerability and to do what they could to mitigate that from coding perspective on the Log4j. It did take some considerable amount of time, but I think that when you touch a code that is being used by so many companies and products and tools on the market, you need to be very, very careful about what you change in it, not in order not to break things. Because if for some reason the fix, the final fix that solved the Log4j problem would have required a considerable amount of effort by the developer to upgrade to that new version, that would have taken considerably longer for them to implement that and release new products, new versions of their product. So I think that they tried to minimize the amount of effort that would be required to upgrade by not killing that feature instantly and just trying to make it work, but to make it work safely.
But wasn't it disclosed like in November? What happened between the time it was disclosed by Alibaba and the time that everything exploded?
Well, first of all, the guy from Alibaba just gave them 3 days to fix it. It's very, very limited amount of time.
Is it considered tight on?
I think that if I was the developer of, and thankfully I'm not, if I was the developer of Log4j and I would have heard by someone from Alibaba that my software is vulnerable in such a way that would affect millions of, hundreds of millions of devices, and I have just 3 days to fix it.
At least 3 days in bed before you even start, I guess. Okay, and then let's go through what didn't go well, or a bit more points, I guess, here.
Yeah, definitely. I think that the most important part is, just like we said, that they have enabled new features that no one really. I mean, you would enable something by default if you think that.
It's the main flow of
yes, if it's the main flow, if 80% of your users would use it, and to be honest, when you talk about Log4j that is being used by so many millions,
it is very hard to guess. And such a feature that relies on an LDAP server, this is not something that comes to mind as something that 80% of my users would use.
Yeah.
So to enable that by default, that was a very, very bad idea. And also, I think that organizations that that weren't very proactive about it. I mean, they weren't. You could have. From an organization perspective, not the developers, you could have created, collected logs and created alerts about them that are around the expected behaviors of your servers and applications. And if you did that, you probably were received an alert when someone tried to use this vulnerability, because if it's your database server and you set an alert that would trigger it each time this server tries to go online, because this is what, let's say, command and control would do. And if this database server used Log4j to log its logs to the database, to log its actions to the database or something like that, and one day you woke up by an alert that says, well, this database server tries to go online to an LDAP server, you would be blown away and would start investigating immediately, and probably would have detected it even without patching anything.
Yeah.
So organizations that did that, I'm guessing, were in much better chance of detecting it in real time. But those who didn't.
Yep. And what happened post Log4j? How do we protect ourselves or prevent?
I think that what Log4j should have taught organizations is that for every application, and actually even application developer, even as an application developer, I would recommend that when you provided your README file, the ways to use your application, what it is expected to do, how to use it. I would add another section, which type of alert I would recommend you to create in your system to detect anomalous behaviors. Because, like I said, if you know that your code would probably be used in ways you can't anticipate, but you do know what the normal flow of your code is. So if you would recommend the users to create an alert based on the logs, based on other systems to detect anomalous behaviors, that would be a good thing. And if organizations would use that approach, they would probably, it would probably pick up on those. In addition to that, it is important to use automated vulnerability scanning. Although it's not 100% bulletproof, because we did see that it took organizations that do Intel feeds quite a lot of time to report which applications were vulnerable. They reported the versions of Log4j that were found vulnerable quite immediately, but to tell you that, let's say, a Logstash or any other application that used Log4j or an Apache server, that took them a lot of time to report. And I think that this is because it's very complex process that you have to go through to make sure that the application that you report as vulnerable, it actually is. And to do that for hundreds of millions of devices and hundreds of millions of applications, that takes a lot of time.
Yeah.
So I think that so it is a valuable thing to do vulnerability scanning, and not just vulnerability scanning at the application level. Many vulnerability scanners would simply pull out the list of installed applications and compare that list against other vulnerability lists, but like I said, it is sometimes would
would miss applications because it takes time to add them to that list. So what you should do is to take every jar file and analyze it to see if it is using which modules it is using, and to compare that list against the list of vulnerable applications and see if something pops up. Another great source of information, of instance information, is obviously Twitter. The developers of the Log4j reported that very quickly, and all the interaction with them was pretty fluent there.
And then we finished Log4j or Log4Shell, and we got to Spring4Shell.
Yeah.
What happened there?
Well, Spring4Shell, I think that it's much of
it's much smaller scale.
In much smaller scale and much ado about really nothing, because it was very, very hard to exploit that.
And what was the vulnerability?
It was a vulnerability in the Spring is a very commonly used tool to do ETL, and that tool also had a vulnerability in it that allowed in very, very, very edge use cases, when you had to get all the stars aligned in the right way to be able to exploit that. But once you did, you were able to inject some executable code and run it. But that also was fixed really quickly. Maybe
how long did it happen after Log4j?
I don't remember exactly the date. I think that it was maybe a month after that.
And did we see improvement in how it was handled by the community and by?
Yes, but I think that Spring is not handled. I mean, in Log4j, it was a single developer responsible for it, but Spring is actually handled by a company, well-established company. So it took them less to fix it, and I think maybe it took them that little to fix it because of Log4j, because they didn't want a bad impression. That was.
I assume after Log4j, just a bunch of hackers were starting to try out all the different products in the JVM, and
you would never believe. Actually, one of our clients told me that that they saw carpet bombing of Log4Shell attacks. They tried to send that payload, that JNDI payload, to literally every field, every HTTP header, every HTTP body, everything, to see in every application, in every URL or something like that, to see if it was vulnerable, and actually offered them the ability to report them about it, and they said, if you do that, we will never sleep, because we will get tons of alerts based on that.
So to that approach, we say always every log is a security log, right? So I'm assuming the application logs, the Java application logs, the audit logs on the servers, of course the DNS logs, network logs, everything around your environment could have hinted if you got attacked or exploited by any of those attacks or any other attack.
Yes, actually, it's an interesting point to make here. One of our clients, some of our clients contacted us and said, we send our logs from, we don't send the logs from our applications or from our, let's say, Nginx proxy or from our Apache servers to our SIEM. We do have a SIEM, but we don't send these logs there because it would cost us a lot, because they charge us by event per second. But we do send those logs to you for observability purposes. Is it possible for you to detect whether we got hit by Log4Shell? And actually, we were able to do that by just looking at logs from proxies, from the application, from the actual containers running, microservices of the application, and when we showed them, they were really amazed. And also by looking at DNS logs, it was even possible to tell whether that attack was actually successful, because you could see
if it went out.
whether that server tried to connect to the relevant LDAP server.
Yeah. And of course, having everything together is even better if you get there.
Yes.
So how can you protect yourself? And I know there's also a few examples of how you can identify that in CoreLogix, or for that matter, any other SIEM, but we've obviously ran this explanation on the CoreLogix interface. You want to give us like an idea of how would you protect or identify or remediate yourself?
Yes. First thing that I would recommend is that whenever you choose an open source product to be, or library to be integrated into something that you develop or to use as an application, thing that I would do is to kind of measure the open source repository heartbeat. For example, it can be the recent change timestamp, the first release timestamp of that product, how many issues were reported, how much time it took them to respond to issues that were reported on the GitHub or any other repository, the number of downloads per, let's say, month or per year also contributes to know that that this repository is something that people actually use. It's not something that would go away. Also, the number of commits or branches opened and closed and PRs. This is also so important to measure how healthy this repository is. In addition to that, is to create alerts, like I said earlier, around the normal behavior. For example, if we talk about CoreLogix, we can use the new value alerts on, let's say, fields like user agent to...
so an alert that will detect if a new user agent that we've never seen before is performing any sort of action.
Yes, because we have seen many organizations which discovered a new user agent called JNDI, which is a good indication that something bad is definitely happening. A new HTTP method, things that tend to be pretty static. If you create a new value alert on them, the value is unbelievable. Also, to create more than usual alerts about the number of connections from different places.
So like a dynamic machine learning alert that will take you if there's more connections than usual, or...
Yes, and also if you know that this server should never connect to the internet, create an alert based on that. You have nothing to lose, because if it will never happen, you essentially paid nothing for it. So this kind of thing, I think that would, by using those smart alerts, by using machine learning, and also by using the security traffic analyzer, which we'll probably discuss in a minute. So in CoreLogix, we have another tool that called the CoreLogix SDA, the security traffic analyzer. It allows you to actually both detect whether a certain server is vulnerable by using vulnerability scanning using Wazoo agents. With a non-standard configuration that we provide as part of the SDA configuration, and also to detect exploit attempts by analyzing the actual traffic going into those servers by using a set of suricata signatures. And also, it is possible by using the SDA to detect whether that exploit was actually successful or not, based on Zik and suricata logs, and by creating the relevant alerts beforehand on those types of events, it is possible to detect that even before this vulnerability is disclosed, even when it is actually a 0-day.
Got it. So how would you investigate this sort of event with CoreLogix?
So actually, what happened in this case, in this specific case, we noticed a strange HTTP event.
in which you can see that the user agent contains the actual payload, the actual JNDI payload. So in Coralogics, there's a feature called Show Graph Row Key, meaning that you can just just click on a field in an event and click Show Graph Row Key, and it would show you all the values that were seen in that field in that specific period of time that you're currently looking at. And as you can see here, most of the time, the user agents that were used were pretty normal, pretty standard. But this one was definitely not the standard user agent. So if we go to another type of event that is produced by the SDA, which is the software event. The software event includes information about software packages used by clients and servers for many types of different communications, both encrypted and unencrypted. And in this case, we saw that the software event contains the same JNDI payload as the software name, meaning that it got it from the user agent. So an alert that that contains the information, that a new value alert based on that information shows that that actually pops up when this value is a new value that was detected. So in the bottom screenshot, you can actually see the actual attack flow, the complete attack flow that someone sent this payload, this JNDI payload, as the user agent to that server, and that server tried to connect outside to the outside world using DNS, using DNS query to resolve the actual LDAP server name. Yeah.
So our conclusion, with a growing amount of companies suffering from breaches, we always suggest to protect yourself. A few things that Yuval mentioned here: vulnerability scanning, subscribe to threat feeds, be on top of the packages that you install, inspect the third parties or open sources that you install, and how common they are, how fast they resolve issues, and what's their latest update. And of course, have the proper alerting in place, the proper SIEM in place. Monitor also your network traffic if you want to get the full picture of everything and actually prevent stuff, but not only monitor or detect them after they happen. And having logs, metrics, tracing, and security in a single pane of glass is always better. And if you want to make it not overly expensive, a product like Coralogics that analyzes everything in stream and then queries that directly from your own remote archive can give you infinite retention at a lower cost. And now we don't have much. We don't have the 15 minutes we wanted for questions, but now is a good time if anyone of the audience has questions for us.
Okay, so are there any questions? Well, while we're waiting, thank you. That was good. That was very interesting. Nice in-depth look. I don't know if there's any questions in the... is this a question?
Yeah, so how do you how would you go around evangelizing the kind of like a tool like the Coralogics or a process around auditing the kind of risks of the dependencies that you have with like a small team, a very small team? So I run a small engineering team, and often it's the case of, risk versus cost conversation whenever we bring up like security issues, things like that.
I can try to answer that. So first of all, there is a cost versus risk factor here, and this is one of the things that we do mention, that we do work a lot on the cost. The cost in Coralogics is typically 70% lower than the closest competitor. But in general, if you put other tools like Coralogics and you want to evangelize that, I mean, security breaches are one of the biggest threats for a business. So we invest so much in producing new features so that we stay relevant. We invest so much in monitoring the system, so we have good uptime and good performance. All those things can, the business can take a hit if it's not advanced enough, or if it's missing a feature, or if it had a stability issue. But if you really want to talk about a death blow, if something serious happens, a security breach can really bring a business to its knees. And for that, I mean, for the amount of spend that you need to protect a small business in a basic way. So we're talking alerting, a little bit of awareness. A lot of the things that Yuval mentioned don't cost money. To subscribe to threat feeds, to check out the right feeds on Twitter to see what emerging threats are happening, to really closely inspect packages that you're installing and open sources that you're installing. That doesn't cost much. That's just awareness. Having the right tool set to monitor all of that and observe everything typically pays off. I think the best way for you to evangelize that within the organization is through examples. So I can give you one if you want. There's one of the larger insurance agencies here in Israel called Shilbit. It was one of the bigger ones. My car was insured with them. They got hacked seriously, and all of the information of all the people that were insured with them was leaked into Twitter. And we're talking personal details, health condition, homes, cars, everything, including military personnel that had an agreement with them. What happened to that company is, and it was a stable insurance company, and it's not like all insurance companies have the best service or the best website or the best performance of the app. But when this happened, they completely shut down the business. So depending on how bad things hit, the risk of cyber attacks is huge. And I think organizations should take that into account.
This is always the thing about companies that get hit by breaches, that you only ever hear from the survivors. The people who go out of business, because they've gone out of business, you don't hear from them. You only hear about the people who survived. And so, the stats often look much nicer than they really are.
Yep. And we're trying to answer some of the questions. I'll actually go from the top. Problem with logs is nobody thinks about them till they need them. That's the right statement, both for observability and for security, by the way. Ashley, thank you for kind of explaining about the confusion part. And I see Dave, is there a wide range of there is a wide range of tools ranging from vulnerability scanning to TIPs implementation. Will depend on cost, resources, size of companies, risks, etc. Yes, but there's a minimum that we believe that every company, any size, should have. And of course, the bigger you are, the more you're willing to invest, and also the more interesting you are to attackers. But there's a bare minimum when it's just too easy. If I live in a castle, I'm definitely going to have security guards and a very good alarm system. But even if you live in a small one-bedroom apartment, if you just leave it open completely, someone's going to come in and steal your couch or something. So just there needs to be a bare minimum of awareness, training, and tooling to protect your organization. To be fair, most SCA tools, that's WTC. To be fair, most SCA tools are checking lists of dependencies.
SCA is one of the checks that are being done by Wazoo as well.
Exactly. So that's one of the tools that we definitely recommend, and Wazoo is one of them. Unification sites offer Log4J exploitation models and machines. Those are just conversations here. There are embedded systems still with not patch Log4J. Yes. So Yuval talked about how hard it is and why it is important actually to scan the jar files of everything you have, because you never know where you're going to find it. So that's a very good observation. That's about the yes, WTC. I would blame culture. An issue often starts there. I agree. Culture, and this is why, by the way, one of the first parts of the conversation we talked about why full stack observability, and security are great because when everyone, including developers, support, QA, are working on the same system as the security teams, and their data is being used by security teams and vice versa, you create better awareness and better culture of securing the organization and being aware of issues. Once you get people together and it's not siloed, you'll just get a more protective organization, and your organization is as strong as the weakest link, just like anything else. A question here is by Dave. Sounds like a heuristic IDS.
It's not just heuristic IDS. It's more than that because it has tons of enrichment services on top of it. Would, for example, detect whether an IP address or domain has been seen, when it was last seen, when it was first seen.
And we enrich with Log4J, right? With the LTAP service.
We enrich lots of information, but not with Log4J.
Okay. How would you prevent? That's from Raf. How would you protect companies from another Log4J? It's impossible to retro test all software you might use.
Yes, exactly. The key component here is not to target the vulnerability, not to target the exploit, but rather target what's normal, or to target the anomaly. And that way you would be able to detect tons of another Log4Js or
exactly. So when we talked about the having those tailor-made alerts to your organization and to basically monitor everything that you don't expect happening or is new, that's the best way to discover unknown unknowns. That's basically your question, Raf. I know about Log4j, I'm going to scan it, but there are unknown unknowns. I can't scan every single thing. You don't have to do that. You just have, so if, again, I'm going to my analogy of protecting my my apartment, I don't have to know each and every criminal in the neighborhood. I just need an alarm whenever someone tries to open my window. And if you have everything in place, you should be able to prevent the next one. We can tell you that once we were aware of Log4j and Log4Shell, and again, we're a company that is heavily reliant on Scala. The first thing we've done is pull the audit logs and the access logs and see if we were already attacked, and we really had a very good view. If we were attacked, we would have known about it. And yes, I think we are good. And there are no security team. Security is everyone's job. I agree 100%. And also, if you don't have anyone that does security in the company, there are many companies that offer those services managed, and they can help you out or at least give you some advice. One of the things that we've done in CoreLogics is open our Security Resource Center, which is basically professional services for security that help 24/7 both detect and build those proper alerts and dashboards, but also help remediate incidents when they happen. Because we saw that there's a big gap in the market. There's a lot of tools, but not enough knowledge. That summarizes everything, I think, Martin.
Excellent. Okay, more or less perfect timing, exactly an hour. So thank you very much. That was fascinating. Thank you for fielding all of the questions. Thank you very much.
Thank you, everyone, for joining. Okay. Check out CoreLogics.com to learn more. Have a good night. Bye-bye.
Cheers, guys.
Thank you.